Look at this. Can we solve it? Yes, we can. What volume of 1.0 molar hydrochloric acid must be diluted to obtain 1 dm cube of 0.05 molar acid? This is a question strictly on concentration and volume and number of moles. What is the question actually asking? There is a hydrochloric acid with a concentration in a particular volume. This, let's say this is a volume. We don't know. This is a volume, V1. And this acid has a concentration 1.0 molar, meaning 1 mole of the acid in 1 dm cube. That is the meaning of this, 1.0 molar. Now, for you to dilute the acid, what do? You pour more water. And as you are pouring more water, the volume will increase. When you pour water, when you introduce water, the volume of the acid will increase, let's say to this point. And what happens to the concentration? The concentration will decrease. This is the V2. V2. Concentration will decrease. Look at it here. It has already decreased 0.05 molar. Why did it decrease? Concentration is the amount in a particular volume. Since the volume increased, the concentration will decrease. Take for instance, if you pour 5 spoons of water in 1 cube of sugar and dilute it, and you place another cube of sugar in a container and pour 1 glass of water, which one will be more sugary? I think the one that has 5 spoons of water. That one is more sugary because the sugar is more concentrated. But the one that has 1 glass of water, the sugar is less concentrated. Yet, they contain the same 1 cube of sugar. So, this one has less volume, this one has more volume. And the concentration will decrease, the taste will decrease here if the acid is sugar. I hope you know. Then, what remains the same is the number of mole, the amount. And the number of mole has a formula. Number of mole is equal to concentration times volume. That's the formula for number of mole. Therefore, number of mole in the first diagram is equal to the first concentration times the first volume. Why number of mole in the second diagram is the second concentration times the second volume. Concentration and volume keep changing, but number of moles remain the same. But number of mole in the first instance is the same as number of mole in the second instance. Therefore, C1V1 will also be equal to C2V2. C1 from the question is 1.0 molar. But we don't have V1. That is the question. It says, what volume will be dilute? C2 is given as 0.05 molar. And V2 is 1 dm cube. 1. Therefore, V1 will give you everything here, 0.05 times 1, divided by this, 1.0. 1.0 and 1 are the same, they cancel. Therefore, V1, that volume that will be dilute is going to be 0.05 dm cube. That is the volume that will be dilute. So if you look at the question, you see the answer is there. So this particular volume, V1, is going to be 0.05 dm cube. So that the number of mole here will be 1 molar times 0.05. Why the number of mole here will be V2, and the V2 is 1 dm cube. 1 dm cube. 1 dm cube times the concentration, 0.05. You see that number of mole, this has proven that the number of mole in the first instance is equal to the number of mole in the second instance. This is the answer, and it is before our eyes. A.